We had some success with the law of sines in solving triangles of various varieties. There are two situations that we didn't look at yet, and that was a triangle where we know two sides and the angle between them, and also the situation where you know all of the sides of the triangles. So let's see what the law of sines can do for us in these two situations. So first, let's go for side angle side. So we might have something like this. And maybe we know that this side is 5, this side is, I don't know, 35 degrees, and maybe this side here is 4. So we know two of the sides and the angle between those two sides. So we'd call this angle big A, this side little a, this is going to be little c, big C is that angle, big B is this angle, and little b is this side. So to use the law of sines, remember we need to have at least one angle side pair that we know in order to use one of the three versions of the law of sines. Looking at this triangle, we don't know both A's. We know the angle but not the side. We don't know both B's. We know the side but not the angle. And we also don't know both C's. We know the side but not the angle. So it seems like with the law of sines, we're kind of stuck here. There's no progress we can make. Just as an example, if we tried to write down the law of sines, let's write the version with the A's and B's. So sine of A, we know A, it's 35 degrees. Over little a, we don't know. So little a equals sine of the angle B, but we don't know that, so just have to write capital B. And the side little b we do know. But you can see the problem here. We get an equation, but it's an equation with two unknowns, and so we aren't going to be able to find either unknown. And the same thing happens if you try to use the version of the law of sines with A's and C's or with B's and C's. No matter which version you use, there's always two unknowns, and so you're never going to make any progress on solving this triangle. Okay, that's a bit of a disappointment. Let's try the side-side-side situation, I guess. So let's see, here's a triangle. And maybe this side is 4, and this side is 6, and this side is, I don't know, how about 3? Okay. Again, let's give everything its name. So there's the angle A, the side little a, the side little c, the side capital C, this angle capital C, the angle capital B, and the side little b. And again, remember we're looking for an angle side pair that we know. But since we don't know any of the angles, we don't know any of these pairs again. So once again, if we try to write the law of sines, we'll have two unknowns. Just for example, let's write the version of the law of sines with B's and C's. We get sine capital B over little b we know, that's 4, equals sine capital C, which we don't know, over little c, that's 6. And again, we have an equation with two unknowns, and so we aren't going to be able to make any progress on solving this triangle either. So I guess what this is telling us is that the law of sines probably isn't all there is to know about triangles that aren't right triangles, because here are two triangle situations where it sort of feels like there ought to be one unique triangle that is locked down by these measurements, but the law of sines doesn't let us find what that triangle is. So we're going to have to work a little harder.